Good morning, everyone. Welcome to the shores of Cebu, the Philippines. It's really hot and humid right now. Hey, are those the natives? Oh, crap. Look, I just want to convert you to Christianity. Lord, no, I want you to, oh, sorry, not Christianity, sorry. Grow crystal, counting dust. Oh, God. Hello, everyone. Welcome to End of Mission, the podcast where I died in the Philippines. I'm Paul, the pressure-fed astronaut, and joining me in prayer today is...
Christian from the face of sarcasm. And I'm actually going to be circumnavigating the globe and taking over your ship.
Yeah. Hi, everyone. Welcome to November now. Isn't this amazing? The live stream I did just last night. Totally. I'm not recording this in August at all.
It's amazing. I was there.
Yeah, you were there. It was either Soma or Dead Space 2.
Yeah, it was definitely it was a great time had by all. Yep, I definitely remember that in the past because it happened definitively.
It was quite wonderful.
Mm-hmm.
We're testing out using Teams instead of Discord. We've had some audio issues, but it's not mine this time.
Finally, it's me and my terrible microphone.
Yeah, who's got the bad microphone now, buddy, huh?
Huh? It's me.
It is, isn't it?
Yeah.
So today, we're doing the culmination of what was launched on STS-30. Magellan. And do you know what these are? Yeah, those are volcanic pancake domes.
Spicy.
We get to learn about volcanism today.
I love volcanism. Let's go.
Yeah, but first, so we've discussed with Vega that America's actually been to Venus like 3 times. Officially. 1 didn't work, 1 worked, and now we're in orbit.
Okay.
That sounds about right?
Is it? I don't know.
Yeah, the Soviets went there way more times than we did.
Yeah, but how many more successful times?
Depends on how you look at it. So the most recent mission is Pioneer Venus 1 and 2. So Pioneer Venus 1 is the orbiter that enters orbit around Venus in December of 1978.
Exciting.
5 days later, Pioneer Venus multiprobe deploys 4 atmospheric probes into the atmosphere of Venus. It's really cool. And one of the probes actually survived all the way to the ground, where it lasted for an hour. Yeah, well, they were supposed to go into the atmosphere and take atmospheric samples. Landing was not part of the plan.
And the pretty, air stuff and the gases.
Yeah,
all that fun stuff. Not the hard rocky ground.
Yeah. So Pioneer Venus is still orbiting Venus at this time, but you want to map the surface because you can't look at it.
So I do. The clouds just get in the way.
Yeah, the clouds are always in the way. It's always smoky. It's Venus. And the radar mapping on Pioneer Venus, it's not that good. There has to be a better way. Yes. This is called Venus Orbiting Imaging Radar, VOIR. Yes. So this was proposed originally in 1981, so they just got there and said, we need a better spacecraft. It was meant to use synthetic aperture radar to map at least 50% of the surface of Venus for future probes and landers, which famously happened. This would launch from Discovery in 1987 and actually aerobrake at Venus. And then...
hot and fast.
Yeah, then mapping would be done at a resolution of 600 meters down to 550 meters at high resolutions. So this is what it looks like. The later proposal.
So, yeah.
It's a dish, and it's mapping.
Shows.
Yep. So this proposal went over budget in 1982 and was then canceled. Whoopsie. It was then scaled back as part of Planetary Observer Program, as we talked about with Mars Observer. It was renamed Venus Radar Mapper, better known as Magellan. Also, there was some radar mapping of Venus's North Pole by Venera 15 and 16, these guys right here, in the mid-'80s. So this looks vaguely familiar, doesn't it?
Interesting. It feels like we should be dropping balloons from this guy.
So instead of having a lander up here, this is a radar. And if you've played Kerbal Space Program, this is the basis for that radar.
To say that looks like that radar from Kerbal Space Program.
Yeah, but they only map like the northern hemisphere, like just like the poles of Venus. Nowhere else you can find maps of this. It's just the poles.
This is Santa Claus?
I guess they were. I don't know.
How do they get all the presents on Christmas Day?
I don't know. And so this is kind of what the radar would produce for imagery.
Very high detailed, very cool. Very cool.
And so the last time we heard from Venera 16 was actually, I think, Vega 1. Vaguely. And then it died. Yeah, it only lasted about 9 months at Venus. So Soviet technology, but, So, of course, you're probably asking yourself, who's Magellan?
Historical figure.
This guy. He's giving us the side eye. Like, you should know who I am. So, Ferdinand Magellan, or Ferdinand de Magellos, I think in Portuguese, but eu não falo português. I don't speak Portuguese, so I'm sorry. He was born sometime in 1480 in Sabrosa, Portugal. Maybe. We don't really... Again, he was born in 1480.
The internet back then couldn't check the calendar?
No, his birth certificate was, you had to etch it in. Find it. He also died on April 27th, 1521. This is important. So he comes from a small, noble, not normal, I guess they could have been normal, Portuguese family. His first claim to fame was serving in the fleet that hosted Francisco de Almeida in the part of India that's owned by Portugal back in 1505. Later in 1509, he sailed to Malacca, which is, so Indonesia is all these islands? He went to the part that's closer to the Philippines. With Diogo Lopez de Sequeira. Then he also helped conquer Malacca with Alfonso de Albuquerque. No, he's not the namesake for the town of Albuquerque. I googled this. I was like, is that really him? No.
Albuquerque, the city.
No, Albuquerque was a title, like a region of like Spain. Like it's like I'm the Duke of Albuquerque. That's how it got its name.
Okay.
I looked this up because I read this and went, no way.
Alfonso from Albuquerque.
Yeah.
Okay.
Yeah, that's how names worked.
Weird.
Now, he liked exploring, but the Portuguese weren't interested in him exploring, so he decided to work with the Spanish crown and plot out a course to the Spice Islands, which is in Malacca, Indonesia, that also complied with the Treaty of Tordesillas. Remember, this is the 1495 agreement that divided the world between, okay, Spain gets this part, Portugal gets this part. Well, this is actually right where the meridian would be on the other side of the world, so he's going to help map that out. King Charles I of Spain would then fund his voyage. And as a note, he's also 18 at this time. Hey kid, yeah, I'll get you some vapes. I'll get you a Nintendo Switch from the Spice Islands. Okay.
Just got the Switch 2 where I can get you that.
Yeah.
Just give me a little bit of cash. I can go to the other side of the world and I get this all stuff for you.
No cap, for real. It's not sus. What's some other? I don't know the lingo of the youth today. Okay. It's rad. It's tubular, bro. Exactly. Whatever that means. So it's called the Magellan Elcano expedition because Elcano is his second in command. So this is Magellan's expedition. It launched on September 20th, 1519, and returns land on September 6th, 1522. It orbits the...
It's like 3 years.
It's a pretty long trip. It does... I wanted to write more about this expedition because really funny and dumb things happen on it. So, this voyage begins with 5 ships and 270 men. And they're going to do the first circumnavigation of the Earth. Ever. Woohoo! Now, if you want a more detailed history, the Scottish pirate metal band Ailstorm actually has a song about it. And this is a screenshot from the music video. Oops. Sorry, let me stop. There we go. And it's 100% accurate. Okay? This actually happened. Okay? History is funny.
It's definitely happened. I believe you, 100%.
Yep. So they start with 5 ships. It gets down to 1. At some point, like, the first stop they make is like the Azores, and apparently there was already like sodomy happening among the crew, and he actually punished someone for that, and that caused a bit of a mutiny. Because again, you're in the Navy, buddy. It's 3 years on a boat with the fellas. Okay, it's just yeah, it's lonely out in the ocean. Okay. At least one of the ships turned back at that point. There was a mutiny. They turn back. They make it to the coast of like Brazil. They sail along there because again they're looking for a way into the big ocean here, which really hadn't. They knew it existed. They just didn't know how big it was. And what?
Spanish Pond.
Yeah, the Spanish Pond. So in October 1520, they discover the Straits of Magellan. Talk about good luck. Hey, there's this place called the Straits of Magellan. Weird. This is important. I gotta go here.
And to me.
It's at a passage at the bottom of South America, between the Atlantic and the Pacific Oceans. And it
sounds like it's south of South America.
Yeah, it's now we discovered later the Torres Straits or Francis Drake, which is a lot safer to go through. Magellan did it the hard way. So then they discover what's now called the Pacific Ocean. And they actually he named it. It's the Pacific Ocean.
Magellan named it.
Yep.
Why did he name it Pacific?
Because it was calm.
That means calm?
Yeah. Pacified, Pacific.
Oh, okay. I did not know that.
Now, he thought it'd be a quick 1 to 3 week trip all the way from here at the bottom of the world to over here.
Quick 5-minute adventure in and out.
Now, as we all know, the Pacific Ocean is a lot bigger than that. It is enormous.
It has antipodes.
So, from November 1520 to March 1521, so about 5 months, they cross the Pacific Ocean. This is where most of the crew then goes, we're going back. We're going back. We're going to go to the Spanish holdings here and the South America, and we're going to go back. This is too much. Okay, you can keep going. Have fun. You can do it. You can take all the credit. Yeah.
Like, oh, we're only going to spend 2 or 3 weeks here, and then 5 months later, okay, we finally made it.
Yeah. They were running out of food and water because nutrition hadn't been invented yet.
The FDA didn't regulate their 2,000 calories a day with different forms of nutrition? No?
See, they're on the ocean here. This is Admiralty law. There's no FDA in the Admiralty law. Which, just as a side note, one of the things I would like to do for specials in the future is just cover some of these old exploration expeditions. Just like, what did Cook do in the South Pacific? Just to show you the parallels and just kind of how funny some of these expeditions were. Yeah. So I think that over here this is Japan, just for reference. And you can see Alaska here, Baja California, Papua New Guinea. Of course, Australia hadn't been discovered. It won't be discovered until the 1600s.
Because Australis down there.
Oh, that's what they called everything there. It's like, there's something there. We'll call it Australis.
And New Guinea is huge.
Yeah. And these are the Solomon Islands here.
Oh, yeah, look at that.
Yeah. So on March 31st, they reach the Philippines. A very nice country. I've been there. It's a really nice country, nice people. And they have their first Catholic Mass ever there.
Fun.
Yeah, because that's the first thing you do is, natives, you're Christians now. Gotcha. And apparently, so he's near Cebu City. And you can actually go to Cebu City right now and see Magellan's Cross where he planted it.
Still there?
Yeah, it's still there. Yeah, there's a little place you can go up to. I actually thought about going there to go see it when I went to the Philippines 2 years ago. But my now ex said, don't go to Cebu. They're all weird over there. And then, so the locals in Cebu City said, hey, there's some more people to the south. They'd also love to be Christian. You should go over there. Trust me, they love Christianity.
Say with their snickering smiles.
So then Magellan decides to convert these people to Christianity, and they don't like it. Magellan and his crew engage in battle with the locals, and the locals kill Magellan on April 27th. 1521.
Good job.
The first man to sail around the world died halfway.
See, that's how I want to be remembered, for accomplishments I'd never achieved.
No, he gets the participation trophy because technically, if you work out the math, he did go technically around the world. It's just not all at once. But it is still really funny, though. He went around the world. We did actually do it. We lied to. You know who actually went around the world the first time? Juan Sebastian Elcano. This guy. He's a handsome fella. He returned to Spain with one ship and 18 men left. And they were starving.
270 men.
A resounding success. See, that's why I want to talk about these old expeditions. It's just, yeah, this brave hero died of malaria.
Decided to convert some people to Christianity, and they killed him.
They did not like that. Not one bit. So let's do the actual mission, the namesake for this.
Second, before we do, I have a quick question. Is this probe going to die halfway around Venus?
No.
Okay, good.
It's a resounding success, don't worry.
In the resound, do they start with 5 of these probes?
No, don't worry. This is a good one. This is a good probe that actually does good things. It's a good boy, okay? Okay. So, Magellan's mission is to map up to 90% of the surface of Venus using synthetic aperture radar.
Okay.
So it's going to send signals with this big antenna here. This looks kind of familiar, doesn't it?
Yeah, interesting.
Yeah. And then the signal will bounce back, and you can use that to map the surface.
Because radio waves are traveling at the speed of light, so you're just timing it.
Yeah, and you also have an altimeter also.
Yeah. Okay.
So all the radar stuff's back here, like the equipment for it. The dish is up here, though. So the goals of this mission are: 1. Obtain near global radar images of the surface equivalent to optical imaging of 1.0 kilometers per line pair. Right? Because you're taking really long streaks as you go. Right? Just long images. 2. Near global topographic map with 50 kilometers spatial and 100 meter vertical resolution. Right? So what's the topography of Venus, right? Is it mountainous? Is it flat? We don't know. We can't see it. Near global gravity field data with 700 kilometers resolution and 2 to 3 milligauss accuracy. Well, it's a really tiny woman. Milligal.
Two or three of those.
Yeah, I take a few of those a day, just to feel a little, just to feel something. And then use this radar data to develop an understanding of the geological structure of the planet, right? Because surface features tell you what's going on. Yeah. So our spacecraft weighs about 3.4 metric tons, 7,600 pounds, wet, and then dry, it's a little over a ton, or 2,282 pounds.
For putting it into the spacecraft to make it dry, or do they just send it?
Well, you got to get out of the ocean to go convert the natives to Christianity and then die. Okay. So that's where that weight's coming from. Yeah. So Magellan is actually made of a lot of spare parts to save money. The attitude control computers from Galileo, the spacecraft bus, so this part here is a spare from Voyager. The antenna is from Voyager. The power distribution system's from Galileo. The hydrazine propellant tank is a shuttle APU tank. Yeah, it is. The traveling wave tubes, which don't worry, these don't break, are from Ulysses. The star scanner is one from the inertial upper stage, and the maneuvering thrusters are from Voyager.
It's stolen.
It's just, it's like, hey guys, we gotta build a spaceship. You guys were building Magellan, right? Oh. When's that due? Tomorrow? Let's go. Okay, get those parts there. Go there. Okay, let's get these parts. Come on, Steve. Go to your garage. Go find some spare parts. Come on.
59 p.m. Come on, we gotta get this thing together.
Let's get this thing together. So this is what the radar circuitry looked like.
Ugh, gross.
Yeah. Apparently they had some soldering issues with it. I read a report on that because Galileo also had some soldering issues that they discovered on it, but they fixed it.
Okay.
Yeah. So when it's sending out a signal, this is what the data collection actually looks like. So when they send out a 5 kilohertz synthetic aperture radar signal, they'll wait for it to come back. Then they'll send out an altimeter signal at 15 kilohertz. And they wait for it to come back. Then they have the radiometer burst and then come back. And then it's back to synthetic aperture radar. I didn't hear what you said. Yeah. Here it is being built. It's such a clear image, isn't it?
Exactly what is happening.
Yeah, so you can see there's
the bus. There's the thing on top of the bus.
There's the ghost of Magellan.
There's the ghost of Magellan haunting this.
He's trying to convert the spacecraft to Christianity.
Excuse me. He's got we got the solar panels.
Yep. There's a star tracker there. No, this is meeting the antenna. Star tracker somewhere else.
Okay.
So you got some of the thrusters. Again, the black and white image isn't clear. The reversed R stylizing isn't clear. This is what it looks like.
These are all the pixels you get, okay?
Yeah. Again, it made it last night. It's like, we don't have time to take pictures. Sketch it. Don't worry, sketch it.
Yeah, that's faster.
Hey, this looks familiar.
We've seen this before.
I know, right? Where? So here it is being loaded onto the shuttle. There's the IUS. There's the IUS deployer. And here's the spacecraft itself, all ready to go. So, it launches on May 5th, 1989, and the launch vehicle is OV-104 Atlantis on STS-30.
Talk at some point.
Yeah. So, the IUS pushes Magellan onto a Type 4 heliocentric orbit because there were concerns that it would interfere with Galileo. Because Magellan launches before Galileo, and they didn't want him to, because they do Venus flybys right around the same time as they did the normal route. So this means it's actually going to orbit the sun 1.5 times over the course of 15 months before entering orbit around Venus in August 1990. We're recording this on the anniversary, or at least near the anniversary of this, because I'm good at timing things.
Weeks later, but whatever.
Yeah.
Close enough.
So then on August 10th at I think 11:43 in the morning, the Star 48B motor places Magellan into a 777.62 by 295 kilometer or 4,800 by 183 mile orbit at 85.5 degrees. Now, this diagram says it's 8,000 kilometers. It depends on what you read.
Stuff. I mean, what's the difference of like 300 kilometers?
Not much. And so this puts perigee actually at about 10 degrees north on Venus. So
why 10 degrees? It just happened to be like that?
It just happened. It's the way I think it's the way they set up like what they wanted to map. Because you can do radar mapping of Venus from Earth. There's Arecibo images of Venus's surface. Yeah, it's just blurry. You can't see much. Now, one of the interesting things about Magellan, because you'll notice that the spacecraft is right, it's the dish, it's the bus, and then you got like the thrusters really sticking out, and then the motor, right? You know why that is? So the problem is, so normally with a solid motor, you'd spin the spacecraft up. So in case there's weird asymmetric thrust, it just compensates out because you're spinning. But you can't do that for Magellan because it'd break. So they had the thrusters out to actually, in case they need to do corrections, the thrusters would actually be out far enough to apply the right torque.
For torque, okay.
Yeah, it's for control. Also just, T-posing for dominance. It's like, yeah, that's right, going into orbit. Gotcha.
But
so now it begins a 1 month long orbital checkout phase. So, right, it's there. Now it's like, okay, do I actually work? Did the VCR player work? Did you forget it back home? Communications lost on August 16th for about 24 hours. Yeah. And then it does it again on September 15th, right before it's supposed to do the mapping phase on the planet. There's another one in mid-November, but most of the teething issues are gone by then. It starts, so something goes wrong. I couldn't find anything specific on what caused that issue, just that they fixed it.
Something broke, they fixed it.
Yeah, like, you want to go back to Cebu? You want to go back there? Huh? We'll bring you to the Philippines, okay?
You started behaving after that, yeah.
Like, okay, I'll do my job. I'll do my job, okay? Jeez. And it returns the first radar map of Venus of its kind. I mean, yeah, the Venera's Pioneer Venus does some of this, but this is what it returns. It is pretty grainy, but again, they're doing the checkout phase. I get a lot better imagery, don't worry. Already you can see some features. A fault. I think this is an aberration on they fixed. But you can see there's fissures, fractures, calderas.
Starting to notice a theme.
There's a theme here. So the mission timeline goes from September 15th to September 1994. The initial mission was just for cycle 1, and then they just kept going with it, right? We budget this much, and then when it works, we do more. So cycle 1 is from September 15th, 1990 to May 14th, 1991. This is left-looking radar mapping. So you can do right or left looking. It's because it's right, you got a feature here, and you're flying overhead. If you're right looking, you'll bounce off this way. But if you're left looking, you'll bounce off this way. It gives you a better look at it. So this radar mapping gets 83.7% of the surface.
90%?
You're getting there. We're getting there. Okay. And since Pioneer Venus is actually still operational at this point, Magellan works with PVO for some interferometry experiments, as you can see in this diagram here. So PVO has a really big orbit. Magellan doesn't. Did I get another image? There we go. So cycle 2 is May 15th, 1991 to January 14th, 1992. This is the rightward looking radar mapping, and it gets 96% of the surface. Yes. Cycle 3 is from January 15th, 1992 to September 13th, 1992. So it does more left-looking radar mapping, but they want to make stereo pairs with Cycle 1's imagery. So they can look for differences and kind of get more 3D mapping. This gets you to 98% of the surface.
Percent purity, Jesse.
Yes, Jesse, come to the Philippines. 98% purity. So then cycle 14 is from September 14th, 1992 to May 23rd, 1993. So this is when they do mostly the gravity data mapping of the surface using Doppler shift with an accuracy of 0.1 millimeters per second. That's pretty accurate. The problem is, with a highly eccentric orbit like that, you can't get that great of gravity data. You gotta lower your orbit. How do you do that?
Right?
Yeah. So, from May 24th, 1993 to August 2nd, 1993, Magellan aerobrakes. This is the first dedicated aerobraking mission ever. Now, technically, Highton did it first, but Magellan actually operationally used aerobraking.
Inspired Mars Global Surveyor to use it.
I actually read the report.
For that mission.
There's actually a few reports comparing Magellan because they're trying to figure out, okay, so how do you do the aerodynamics calculations for a spacecraft aerobraking in an upper atmosphere in anticipation for Mars Global Surveyor? And they talk about like surface area and things like. I actually read some of the reports. They're really hard to decipher unless you like aerodynamic coefficients and constants, to which, again, stay away from me if you do. But they actually lower the orbit to 540 by 180 kilometers. 770, down to 540.
3,700.
That's what I meant to say. Again, that's what I was thinking for a second. Gosh.
Mm-hmm.
So cycle 5 starts right after that and does gravity data to 95% of the planet. And I couldn't find a good gravity map of the surface, but you can kind of guess what the gravity map looks like. Okay, just you can guess.
I'm picturing like rainbow colors.
Yeah. So then after that, in September 1994, what's done is called the windmill experiment.
Ooh.
So it's more aerobraking, but this time the solar rays are aligned a certain way so that when it hits the upper atmosphere, it'll start torquing, right? And you can use because you have gyroscopes on the spacecraft, you can measure the torques, and you can use that to back extrapolate atmospheric data. Yeah. It's really useful if you want to do aerobraking in the upper atmosphere of a planet.
Pretty useful, yes.
It's very useful. So this is a surface map of Venus, so we know where everything is, based off of Pioneer Venus data. Yeah, so it's not as accurate, it's not as clear, but you get the rough shape of where everything is, and you'll notice you're only getting up to about, 75 degrees north and maybe 65 degrees south. Yeah. Who cares, right? There's nothing up there except a polar vortex. All right, so you can kind of see roughly the shape. You have Ishtar Terra over here. Or this is Aphrodite Terra. Ishtar Terra is up here. Yeah, as you can see, I'm very smart. So right, here? So this is the equator. This is this is one spot. And then over here is, on the other side of the planet. And so the Vega probes landed, somewhere around down here or somewhere around down here. Around here or here. Yeah, because I think one of them was near Aphrodite, over here. Yeah, and then the other one, you can go watch that older episode. Okay, this is just roughly where things are, right? So up here you got Maxwell Montes on Ishtar. You can see look, yeah. So let's look at Venus. Just to show off how good Magellan is, the image on the left here is the same spot taken by Pioneer Venus, which is blurry and blobby, and this is what Magellan produces. A lot more high fidelity. And then polar regions, this is Venera data. On the right, this is Venera, and this is Magellan. Same area. Much higher resolution. And you can look, volcanic features.
See a theme.
Wow, right?
Yeah.
Isn't this exciting? So here is Lakshmi area. This is Lakshmi Regio, I think it is. And you'll see there's what are called lineations. So these are like faults and like fractures and wrinkle ridges, as you can see here.
Yeah.
And you can see there's also crisscrossing there, because again, volcanic features. Very little tectonic activity.
Tectonic activity.
Yeah. And then over here, we have what's called the Stein triplet. So there's 3 impact craters here. Now, no, these are impact craters. There's actually a few of them on the surface.
Wow.
Yeah, there's not many, though. Now, you'll notice a lot of things from this image already. You'll notice, so there's a lot of radar bright stuff around the craters. You also see flows, fractures, and faults, and channels, and that's Venus. So over here on the left is a 66-kilometer diameter volcano. It is really big, and isn't that cool looking too? So this is the crater here, and you can see part of it's a bit collapsed too, like some landslides. This is redacted over here, and then, yep, that's the secret military base. And then you can see, again, more wrinkle ridges and lava flows all wrinkly all over each other. And again, just to remind you, these are radar images, so these are radar bright things. There are things that are bright to radar and things that are not bright to radar.
This might not be visible if I was to be able to see it with my eyes.
At this resolution, this is probably visible features, but it's just, this is radar bright.
Okay.
Yeah, because so the image on the right here is Sapus Mons area, and you can see lava flows. That's the bright stuff.
Is that active lava flows?
No, these are all dead lava flows. But again, different radar profile because it's different types of lava.
Okay.
And you'll also notice an impact crater. And, linear features. So you can also see there's also darker lava flows over here. Again, just get ready for the phrase lava flows.
I'm noticing a theme.
So over here we have another impact crater, but it's been cut in half by a lava flow. I know. Wow. But you can see there's a lot of like geologic features here, right?
Seems to be nothing but geological features.
It's a planet made of geology. Weird.
Yeah.
It's not like Mercury or Mars, which is like impact craters, like the moon, which is just impact craters. This is volcanic activity. And you can see, crevices, valleys, regios, they're called. Then you have pancake domes, which are, so pretty much it's volcanic upwelling, and then it rises up like a pancake and then collapses. So in some of these, if you look closely, you can actually see kind of like a this shape to them. You can see that, right?
You can see that, yes.
Yeah, and some of the other images, you can see that. Also, if you look over here, here's another feature. You can see channels. There's a really big channel over here. And radar dark lava flows over here. So actually, one of the theories on how some of these surface features form is that the magma flows over them, and then, like, as it contracts, it makes the cracks.
Sense.
Yeah. Or some of it flows under and then collapses. It's really interesting. I'm not a geologist. I'm sorry. So over here, we see some more streamlined flows and channels, as you can see. Yeah, it looks like rivers, too. Yeah. Yeah. And then, so here on the right is Mylita fluctus. You can see the different lavas, different flows, and volcanoes.
Think about volcanoes, yes.
So these volcanoes are about a mile wide, for reference.
Oh, so they're kind of small.
They are kind of small, but you can see also like the radar bands. Like if you look closely down here, you can see the different passes.
Yeah.
Because again, it's looking at one spot. Again, it's like taking a panorama with radar. But you can see like all the fracture features too, which is cool.
It's just everywhere. It's just a whole mess.
Yeah, and then so again, like so, some of the stereo images can actually produce 3D imagery of like Golubenka crater here, where you can see mountains, Central Mountain Depression, and over here, we have Adavar crater here. You can see there's a bit of a collapsed section here, but again, radar bright stuff from the impact itself. And then you see outflows of material, scoured regions here, and then fracture features, different lava flows. It's geology. There's just geology. So over here you can see a bunch more lava flows along with so the dark spot here is another impact crater. Here's an impact crater. There's another one like up over here. But again, you can see there's channels up over here. You have so I think the dark flows are Pahoehoe flows, and the bright ones are A'a flows. The name for the Hawaiian words for different lava flows. Yeah, that's the nomenclature we use, what the Hawaiians use. Because I guess if you live on an island made of volcano, you know what volcanoes do.
Assumption, but okay.
What you can see here is there's just a lot of like flows interacting and intersecting each other. Some of them crack and crag, right? They make different features. It's really cool.
It's very, very vibrant in terms of its geological features.
It really is, and it's not just impact craters.
Yeah, it's nice. It's not gray rock with impact craters.
Yeah, weird. So over here we have rift areas up here, and you can see different faults and fractures. Shocking. Which also suggests that like crustal shrinkage too. Like some of the rift valleys suggest that. So that's pretty cool. And then so these domes, you can see the ridge feature on the domes.
I see that.
Yeah, and these domes are about 65 kilometers across. They're enormous. And
it's giant.
You can see other, like the shape, again, the faults, the wrinkles, different flows, and different types of flows. So for over here, I think these were caused by like underground flows collapsing. Yeah. Because the other thing, there's another feature they're called arachnid features, because they look like spider webs of like the fractures overlaying each other.
Has that web look to it?
Yeah, it's really cool. Then on the right, we have the largest crater on Venus.
Oh.
Mead crater, named for Margaret Mead. I think she's an author. I know
like, is it like Mead Lake? Lake Mead? Like the one behind? Oh, okay.
That's a different person.
That's a different Mead. Got it. Sorry. Yeah.
History, we're good at that too.
Mm-hmm. Yep, definitely.
It's the heat of the Philippines, okay? It makes things a bit slow. The air conditioning's really going. When I was at my hostel in the Philippines, because I got a room there for $65 a night, by the way, I had the air conditioning running. There was like a puddle on the stairwell because it was draining onto the stairwell, and there was a puddle under it. So I felt really bad for a bit, but it was the Philippines. It's hot and it's humid.
Filled with water.
Yeah. But but you can see just such interesting features, and you got like the rifts and the crags and all that fun stuff. It is just a really pretty world. If only we could see the surface normally. Yeah. So over here are fractured plains that show a lot of, again, impact craters, but also you can see small 1 kilometer volcanoes over here. You can see like fractures and channels, but you can see like the fracturing here suggests a lot of geology that's happening.
To the rest of the planet that we've seen so far.
Yeah, this is completely alien. There's no place on Venus that looks like this.
No, I mean, to have a collection of small volcanoes and impact craters and various different fractures on the surface.
I know.
There isn't any other place on Venus like this.
Yeah. So on the right we have a complex crater system. So we can see there's darker outflow over here.
Mm-hmm.
And they got channels, lava channels going around here.
Mm-hmm.
And we can see a bit of it's collapsed right here. A chunk of it's kind of fallen out.
Mm-hmm.
And there's a volcano. Wow. So over here, this is Siddon's crater or Siddon's caldera, right? Because you can see the caldera here. But these features are collapsed lava tubes. Yeah, that's cool. And then you got ridges and lava flows. And so over here we got some ridges. This is near Adva. This is near the equator on Venus. And you can see these big ridges here, but you'll notice there's some going perpendicular to it, right? So there's a theory that some of this is actually caused by wind on the surface.
Melted by the wind.
Yeah, so there's that might be some erosion caused by wind on the surface.
I mean, it's not like it has a really thick atmosphere.
Yeah. We'll discuss the atmosphere and wind erosion at the end, but there's a theory for this. And of course, you can see the cool features and the different colors of lava flows. Shocking. So over here is a volcano that's about 5 kilometers wide. And you'll notice, trailing behind it, is a streak of radar-bright material. This suggests that there is some wind transport of dust and particulates on the surface. Yeah, because you can see the streaks. You cut out.
I said, yes, good. We can count that dust.
Yeah, there's a lot of dust to count. So on the right, we have the Atla region. This is a very large image, by the way, like the area it's looking at. And you can see a whole bunch of different features, like volcanoes, outflows. You have fissures and fractures, and you can see the different lava flows here on the surface, which, again, isn't that cool, though?
It's awesome, yeah.
And you can see the different volcanoes, of course.
Yep.
And the different, like the volcanic outflows of those, these eruptions, the different like radar bright, different types of flows. This is very interesting. I'm just not a geologist. This is still very interesting for geologists to look at the surface of Venus, because there really is nothing like this in the solar system, really. But that's driven by Jupiter's like internal tidal heating.
Yeah.
And Venus is thought to not be very geologically or tectonically active. So Io's a bit different. Also, Io's made of sulfur. This is more like olivines and pyroxenes and more Earth-like stuff. Again, it's Earth, but not good. So one of the things that was discovered on Venus, and we're seeing part of it here, is a 7,000 kilometer long lava flow channel. This is bigger than the Nile.
What is this?
Yeah, it is really, really big. And there's a volcano.
Yeah.
So it's kind of, you can see it kind of, again, it's a lot like a river, right? It's just kind of meandering along. It's a giant channel that's 7,000 kilometers long. Now, this is just a segment of it. But it's enormous.
1,000 miles, gosh.
Kilometers. So it's
kilometers, sorry.
Whatever.
So it's like 4,000 miles? That's not that big.
It's pretty big, though. 4,000 miles? That is...
I mean, that's further than the width of the United States, but,
Yeah. So on the right, we have the Danube Mountains. There's a volcano.
Mm-hmm, yep.
There's the volcano caldera, collapsed lava tube, and you can see kind of the edge of the ridges here. And you can see that you are looking at it from either right or left, looking at it by this. Because if you look at pictures of synthetic aperture radar of Earth, you'll notice this. You'll see the difference between right and left leaning. So, but yeah, you can see again, there's like different features. Now, these I think are just aberrations from the radar. I think.
Like lava tubes.
It could be that too. And landslide features as well, because those happen. Because I think it's the next slide. It's not, but it will be. So these are the Acna Mountains, which are really pretty, and an impact crater. Yeah, so these are the Acna Mountains. You got some collapsed craters, lava outflows. There's some ridges here you can see. I know, on Venus? Wow.
Strange.
So the basic image here was just, you can see a lot of features like domes and what's called graben, which is like texturing caused by like volcanoes and things like that, graben features. Those also appeared on Mercury also. So, geology. This other thing that we're looking at were collapsed volcanoes and landslides on the surface, right? What's going on in the features? So you can see here, there's some collapse that happened of this volcano. And you can see the outflow here and here. And then on this one, you can see it's, yeah. And this one, you can see it's also collapsed and had landslides.
The remnants, right?
Yeah.
Got it. Okay.
Yeah. And look, volcanoes.
Don't forget the ridges and the fractures.
Oh, yeah, those features and different flows.
Yeah.
So this image here is what's called Artemis Chasma. It's the size of the United States east of the Rockies. That's this feature here. And you can see the different slices of the radar just to kind of give you a rough scale of the features. It is very big, and we'll see it in the big map of Venus at the end. And then over here is Adva Regio with, shockingly, more geologic features. This is also a really large image. And you can see the different, again, flows, fractures, impact craters, flows, crustal shrinking a little bit going on. You can see like river deltas of lava. So these are some ridges that exist on Adva Regio near the equator. And so this is about 20 kilometers across. Not that big, yeah. But you can see the flows, you can see the shaping of geology here. Again, if I was a geologist, I'd be like, of course, this fracture, this thrust fault, all these different things, Instead, so the rocket worked good.
So take a picture of these rocks, and those rocks, some of them are brighter, some of them are darker.
Yeah.
But you notice they're going to have linear features, they have ridges, they got mountains, they got valleys, they got flows, got all the things you would expect of a volcano planet.
Yeah, so this is a 200-kilometer long sinuous channel. It's like a river, but lava. This also suggests the different viscosities of the magma flows on the surface. Yeah.
It's viscous.
Yeah, again, the versus the Pohoihoi flows.
Exactly.
I hope that pronounced that correctly. Is pretty easy to get because it's just AA, but I'm not sure about the other one. A Hawaiian will get really mad at me. They will.
Section below, and you'll definitely read them.
Yep. So this is the Navka region, and that is Venera 8, the first spacecraft to successfully land on Venus.
Exciting.
Well, okay, this is like where it melted, obviously. It's not still active. But look, darker lava flow, radar bright, fractures and faults. Then on the right, we have what's called Bahet Corona. So these are caused by like uplift a little bit. Because again, very little tectonic activity is occurring. So it's like hot spots that cause uplift and like it shifts around. Yeah, so that's what this is. That's what this corona is.
It's tectonic.
Yeah,
activity.
Localized tectonics. Earth may have been like this back when it originally formed, where it was like this, but obviously Venus is still, it hasn't moved on, right? It's still there. It's still doing this, Yeah.
Got this.
You are 45, okay? This is a Little League game. But obviously you can see more, like, again, the wrinkle ridges, the arachnid features, volcano dome, scouring.
You expect to see.
In the description, of course, I've linked a lot of papers that talk about geologic features of Venus, so you can read about them on your own. Because I'm not a geologist. I'm an engineer.
And to be one. Oh, okay.
No. Again, I like geology. I think it's interesting. I'm just bad at it.
It's a rock.
Yeah.
This is a different rock.
This rock is different because, look at it. So on the left, we have Barton Crater. So this is named for Clara Barton, a Civil War nurse. You've probably heard about her. Yeah. It's another impact crater. You can see a double ring feature. Hey, look, volcanoes. And yeah, there you are. And so on the right, these are volcanic vents in the Lavinia region. Yeah, so it just drains magma. Again, it's little holes that magma comes out of. It's different. Because I'm a geologist. So this is in Hestia rupees. You can see more fractures, and this is about 50 kilometers long, so about 30 miles. Yeah, it looks like a stick bug, yeah. Or lightning. And again, you have radar bright features, mountains, lava flows. It's geology. So this is the Sif volcanic structure here. And you can see an intermingling of a lot of different volcanic flows and lava flows. I think the brighter ones are higher viscosity, and the darker ones are lower viscosity. Something like that. We can see there's a big, intersection of them all.
These lava flows.
Yeah. And on the right, we have Sacagawea Patera here, which is a plateau, basically.
Oh, so it's just a little...
Yeah. And also you can see here it's been moving this way because it's all wrinkly.
Plateau has been moving?
Maybe. Again, in geologic terms.
Okay.
Or it's the thing... Wait, again, I'm not a geologist.
Let's just say it is moving. It's part of local tectonics, and it's moving.
It's on the move. It's going. So then over here is, you can see there's a lava flow, and it met a ridge, and it went over the gap. So you can see again, which is really cool, by the way. This looks really pretty.
Yeah, it does. That's awesome.
Yeah, it is so cool. This is so fascinating. I just don't understand it.
That's a bright rock. That's a dark rock on radar.
Yeah, and you can see mountains and ridges over here. And
yep.
so it was flowing from a volcano about, I think it's like 50 kilometers that way.
The scale of this image, so I have no idea how far away that is.
I was reading the description of the image for this, and I think it's about 50 kilometers that way, and that's where it's flowing out of. And again, so volcanoes are a lot like shield volcanoes here, because we're going to erupt until we don't.
So basically just big, wide, and flat.
Yeah. So Mont Mons is one of the biggest mountains on Venus. It's a giant volcano, shockingly. Mm. And so these are volcanic domes on the flank of the mountain. It's on the side of it. So it's got its own, these are its suns, right? Yeah, you can see different outflows here. Different wrinkle features here. Different flows. So over here is Sax Patera. It's droopy. That's what...
Because of the local tectonics that we talked about.
Yeah, or it's collapsed. I can't remember.
I mean, based off of the flows, I would assume it's collapsed, but...
I just finished the slides yesterday. I've been doing things. And then we have Stefania Crater here, which is... It's interesting because only part of it, right? Part of it's collapsed, and there's the dark flows there, and the fractures kind of coming in to grab it. Ooh...
All those spiders that are making all this stuff, they're coming in.
But you can see the arachnid features here, right? It looks like spider webs and like spiders.
It's scary.
Yeah, I am very afraid of spiders. I was mowing my lawn last weekend, and at the corner of my house where the fence intersects with my house, there's an orb weaver, I think it's called. It's the black with the yellow spider. It's kind of big. It shows up in gardens a lot. They're chill, but I was mowing as I was getting close. It ran across its web, and I went, "Oh god, that's really big and scary." It's not that big or scary. I saw that. I was like, oh, that's a spider. I'm scared. And I was weed whipping around my fence, and it was like garden spiders. I don't know what they're called. Like they're kind of biggish. I saw a really big one. I went, I'm keeping my distance from you. You're scary.
It's on a stick, right? So you can stand really far away from it and keep going.
Yeah, that's what I was. Yeah, I am afraid of spiders. Okay, I just don't like them. They're scary.
They are scary. They're creepy.
So this is Isabella crater, the second largest crater on Venus. It's 175 kilometers wide. Here it is. Look, outflow.
That's a remarkable feature I've never seen on Venus before.
Never seen. Unique. That's why they took a picture of it.
Ah, yeah. Mm-hmm.
Different ridges, different volcanic flows, and this is really pretty though. You can really see where things move.
Blows out too. Yeah.
Yeah. Excellent geology. Fascinating geology.
Mm-hmm.
Rocks.
Yeah.
Now, so between cycle 1 and cycle 2 in this area with wrinkle ridges, you'll notice there's some slight differences. You can notice it's slightly different. That's probably because of wind. Moving dust to change the radar properties of the ridge.
Cycle 1 left looking and then cycle 2 right looking?
Yeah, there's a bit of that, but if you look, there's also in the rest of this image, there's like cycle 3, but it's incomplete. It does change over the cycles, which suggests that there is wind moving dust and transporting it to cause some geologic feature changes.
Okay.
So.
Got it.
So these are part of the more famous images of Venus you've probably seen because they were colorized.
Yep.
So here on the left is Leda Planitia, which has got a whole bunch of features we've discussed before. Craters, flows, ridges, all the good stuff. Yeah. On the right, we have Ushas Mons, a giant volcano, and volcanic features. Then this is Sapis Mons here. It looks like 2 volcanoes. Yeah.
Is it 2 volcanoes?
Like 2 craters? Yeah, it probably is. And then you can see the different outflows and different obvious, different geology. Then here is Alpha Regio, which is really big. It's a giant geologic feature. More geologic features. And then, because we have stereo and topographic imagery of Venus, these are 22.5 times exaggerated vertical profiles of different volcanoes on Venus. So we're sitting like 50 kilometers away from some of these mountains, and we're looking at them at a certain height. So on the right is Gula Mons, and on the left is Mat Mons, and there is a little... So that's a palm tree from the Philippines. Someone's chilling there. Yeah. So this is the Galindo Quadrangle, again, producing stereo images, which means we get some 3D imagery out of this. So you can see the different geologic features, like volcanoes and mountains and fractures and... I know.
Features are.
And railroad tracks, I guess.
Somewhere.
Yeah. So this is the Tessera terrain. Again, 3D modeling. You can see now. Ignore these divots; those are just anomalies from the radar mapping. Yeah. Again, mountains, ridges, geology. Then over here is Sedna Planitia, another mountain range. In colorful imagery. And this is a full map of 98% of Venus. You can see a lot.
I could see volcanoes, I could see ridges, I could see fractures.
So this was Alpha Regio, which we just looked at.
Oh, okay.
Right, so up here's, I think Mat Mons is up there. Is it Maxwell Montes?
These.
Because it's the tallest mountain on Venus.
Yeah.
And you can see here, see these are the big channels in the Adva region. Giant channels. Fractures, volcanoes. Right, so there's Artemis. There's the Artemis Coronae.
It's huge.
It is really big. And it just really captures the scale of just, this is a planet that doesn't have much tectonics, and that's what happens to you if you don't have much tectonics.
Stay in school, kids.
Yeah, don't have plate tectonics. All the cool kids do plate tectonics.
All of your friends did plate tectonics.
Yeah, they'd be cool.
Yeah, so you should do plate tectonics.
Exactly. So let's take a look at the atmosphere of Venus, what we learned.
Yes.
So they gathered, and I read the paper on this, it's very complicated, it's really bare bones.
Mm-hmm.
The estimated density of Venus's atmosphere at 165 kilometers, so that's pretty far up, determined by the reaction wheel torques as it was coming in. So you can see, it comes in, the atmosphere is pretty dense, it's buffeting, and then it gets back out. Similar thing happens here based off dynamic pressures from Magellan aerobraking. Because remember, if it's getting drag, it's accelerations, and you can measure that. So you can kind of guess what the atmospheric properties of Venus are like. And that's a cool image I saw of aerobraking, so I decided to include that. It is really cool. It also has like 5 pixels.
It still works. It still gets the idea across.
It is really cool. And with aerobraking, the windmill experiment, all good things must come to an end. It is time to die in the Philippines.
Thank God.
So around August 1994, the voltage from the solar rays and the internal voltage of the spacecraft was dropping to around 24 volts. Anything lower than that in the spacecraft wouldn't really work. So NASA said, well, we got to get rid of it then. And what's the ultimate way of doing this?
To space and overpressurizing the tanks until they explode.
No, that's... What are you talking about? No, you wait until the engine falls off. It's different.
Oh, yeah, of course.
You dunk it in the atmosphere of Venus, of course. So, on October 11th, 1994, Magellan fired its thrusters for the last time to lower its periapsis to 139.7 kilometers, which is about 86.8 miles into the atmosphere of Venus. It is well within the atmosphere of Venus now. Like if you played Kerbal's... Again, if you play Kerbal Space Program, it's just like Eve. And as we talked about with Vega, of course, like they hit the atmosphere, and then it's like, okay, we're done with the heat shield now. We're like 100 kilometers up. You know? Then on October 13th, 1994, at 10:05 UTC, Magellan goes silent due to occultation. It's not looking at Earth. And then when it's supposed to come back, it doesn't. Magellan burned up in the atmosphere of Venus, but parts of it may have survived to the surface. Yeah. So, here are the biggest results from Magellan. A resounding success of a mission, I would say. Venus is shockingly mostly covered in volcanic materials. There are very few craters, which means the surface is likely less than 800 million years old. I think it was
800 million years?
I think there was a bombardment period back then.
Okay.
Lava channels over 6,000 kilometers long suggest low viscosity lava erupted at high rates, right? Because it's low viscosity, it flows really well, and it's moving really fast. Because I was like,
that's how it can cover the distance.
So I was like, cool down to 900 degrees and, freeze.
It's a little too chilly.
Yeah, ooh. Yeah, I could have put my jacket on here to keep warm.
Yeah.
Pancake domes suggest lava produced by extensive evolution of crustal rocks. So it's just sitting there and evolving. Instead of just sitting there, I guess.
Instead of like doing the whole conveyor belt plate tectonics that Earth does, it just
yeah. So eventually, it's gonna grow fins and start walking on the surface.
As that happens, yeah, of course.
Yeah. There's no tectonic activity. Instead, a system of global rift zones and coronae, which is mantle upwelling and subsidence. So it's going to rise up, melt a bit, come back down. Rise up, come back down. Or it's going to split open. There's no evidence of substantial wind erosion and transport of dust and sand, which is the exact opposite of Mars, which is very much shaped by wind and dust and sand.
There's dust storms that cover the planet.
Now, no tectonic activity was the common theory until last year. Someone started looking at Magellan data again. Now, if you look on this image here, this is near Mont Mons. This was taken during Cycle 1 very early into the mission, right around here. This was taken 8 months later. You'll notice there's an outflow.
Isn't there?
Magellan actually witnessed over the course of 8 months, Mont Mons developed a volcano dome and it vented. They found, I think, 8 other sites with this kind of activity.
There is activity happening on the surface.
And there was a new study that came out back in 2023 that said that the pancake domes might actually, and coronae might actually be evidence of real tectonic activity happening. So Venus might not actually be as dead as we thought.
Okay, so that's a shift.
It is a bit of a shift. So there is still some active volcanic activity on Venus.
Dang, just not global. Just like that, all the big stuff we got here on Earth.
Yeah, Earth's pretty cool. Just like the one in Kamchatka from the big earthquake a couple weeks ago. The 8.8 caused a volcanic eruption in Kamchatka.
Damn. Okay.
Yeah. The Kamchatka Peninsula has a whole bunch of volcanoes on it. Yeah, it's on the Pacific Ring of Fire. Shocking. The Philippines has volcanoes like Mount Pinatubo, which famously erupted in 1990, I think. Yeah, because there's a whole bunch of images from that. But yeah, so Venus is actually still volcanically active. And that's also the value of these missions in maintaining all the scientific data. This mission ended in 1994, over 30 years ago, and we're still finding new things from it. Yeah. Now, there have been 2 follow-ons for Venus to help with mapping and observing the planet. So on the left, we have Venus Express, which actually discovered a polar vortex at the south pole of Venus. Yep. That mission ended a couple years ago. And then we have Akatsuki, which is the Japanese mission that failed, basically. The engine throat had issues, so they couldn't go into orbit when they wanted to.
I see a theme.
That one died a couple of years ago. They just stopped transmitting to them. It's like, oh, I guess it's dead now.
I don't want to talk to you anymore. It just died.
And we are actually doing Akatsuki about this time next year.
Okay.
Yeah, so we'll talk about it, because it's also got a solar sail mission attached to it.
Okay.
Yeah, that'll be fun. And there are some proposed missions to go back to Venus, just because there's the detection of phosphine, which probably wasn't there. Venus is interesting. The problem is, it's just, you can't really look at it.
Weird stuff over it, covering all the cool geological features.
And going to the surface means you go for about an hour and then die.
It's a one-way mission.
Yeah. So that's why Venus is kind of interesting in that regard. You want to go there. It's just not much to see.
Venus does not want you there.
It doesn't want to be converted to Christianity. Okay? It doesn't want to be converted to Christianity at all. It's going to resist that. Okay? But that is Magellan.
That's incredible. That's awesome stuff.
It is an incredible mission. A lot of really cool data, a lot of geology, a lot of volcanism, shockingly.
The volcanic planet, that's weird.
I know. That is really weird. That's Magellan. I had a lot of fun reading about this one. So our next episode is about radar, isn't it? Radar mapping. The musical. Woohoo! Yep, you are doing STS-99 for the last shuttle mission of the year. But don't worry, we have 2 shuttle missions to start off next year. STS-72 and... Yeah. That'll be fun. Yeah, that is Magellan. A fun mission. Volcanoes. Some audio issues that I'll tell you about after this is done recording. Any final thoughts on Magellan?
It seems to be just basically the same stuff all over the planet, obviously. Yeah. And just don't try and convert people to Christianity who don't want you there.
Yeah, they don't appreciate that very much, apparently. It is kind of funny, though, because one of the funniest things to do is just look at a map of the Spanish Empire and then look at maps of countries that are Catholic. It's a very interesting map because it's just 1-to-1. Yeah, that's why the Philippines is Catholic where everybody else isn't. Yeah, that part of the world. Yeah, that's how I find them out on online dating too, because sometimes Filipinos like to say they're in America, but they're not. Well, obviously here's Austin, Minnesota, and the tropical beaches. Yeah, there we go. But you're also a Catholic Asian. Okay, I'm assuming you're a Filipina. But yeah, really cool mission. Radar mapping. So, I'm gonna build a radar mapping system. I'm gonna map stuff with my own radar. I have to learn electrical engineering first. Unlike Venus, which is very hot. Magellan.
Listening, watching, staring at the screen with your eyeballs to the point at which they start tearing up. Be sure to like, comment, share, and subscribe. Do all the YouTube stuff. And this has been End of Mission.
Amen.